Hey there, Emmanuel here from WebDevFuel and welcome back. In this video, I'm going to go over Effect, which is a library that helps us improve TypeScript, and I'm going to explain why I've been playing with it more and more these last weeks, and why it improves much of the experience as a web developer when it comes to building web applications with TypeScript, especially on the front end, because I've not given up on the Go for the backend. And I'm also going to explain how this connects to a better user experience in the end, which is the most important thing at the end of the day. So if we take a look here at the documentation, I have here a very simple web application that I'm building. And I'm going to be releasing a course on how to use Svelte and Effect on the front end and then Go on the back end. So if you're interested in that, I'm going to leave a link in the description down below so you can take a look at it and get notified when it is released. So as you can see here, we have the documentation of Effect. I'm also going to leave a link in the description down below to this. And Effect is a very complex thing. So it has a lot of things going to it, but the main point, at least from my perspective, is that it improves a lot of the ergonomics of TypeScript, and it allows us to sort of have built-in things that we would have in other languages like Go, and I'm going to explain why in just a bit. According to the documentation, it says here that Effect is a powerful TypeScript library designed to help developers easily create complex synchronous and asynchronous programs. So the gist of it is that it improves our work as developers. So we have here concurrency, composability, resource safety, type safety, which is one of the most important things here. Error handling, also it sort of brings many ideas from the Go ecosystem, the Rust ecosystem, so languages that use errors as values. And it brings those ideas into TypeScript, which makes, in my opinion, our work much easier. And since I've been using it, I haven't really felt the pain of using TypeScript when it comes to error handling. So when parsing JSON, for example, previously, when making HTTP requests, when doing all sorts of things before using Effect, it was very much a pain because I had to have all sorts of workarounds to be able to have quote unquote proper error handling. And it also has asynchronicity and observability. So these are the basic concepts of Effect. Now, besides this explanation, which is here in the documentation, from my perspective, it helps us build much more correct programs, which is what I really enjoy about Go. And Effect also allows us to do that in TypeScript. And when I'm using it, a lot of the times my mind goes to, oh, so I usually do this actually in Go. I used to do this in Rust. There are a lot of concepts here that are taken from those more type-safe languages. So we have here the documentation for installation if you want to go over it, but if you already have a project, which is the case for most of you, we simply need to install TypeScript, make sure that you have it installed. If you're using SvelteKit, which is the case for the project that I'm building, then all of this is already done for you. And then you simply install here the Effect package. And by installing this, you have access to everything that Effect provides. So a couple of things that are most important to keep in mind is that it provides us with error management. So we have here two types of errors. We have expected errors and unexpected. This is very simple, also applies to errors, let's say, in the Go ecosystem. We have things that we expect to happen in our program. So if we make a request to an HTTP server, we expect, for example, the request to timeout. We expect the JSON object that comes back to not be parsable by our code. And these kinds of things, specifically this point about parsing JSON, is something that usually is ignored by a lot of JavaScript or TypeScript developers. If we use the json.parse command, it actually doesn't throw any kind of error. But by using Effect, we'll be able to do that also with the schema side of things, which we'll take a look at in just a second. So we have a lot of things here that we can take advantage of. We have fallback error values. We have matching, retrying. We have timing out. And yeah, this is essentially the idea of it. We have expected errors and unexpected errors. And the effect program, the error that is expected to come back, to be returned, is always the second type. So this first type usually, not usually, this first type is the thing that is going to be returned when the program actually runs successfully. Here the second type will be the error, and we also can have a union here, so that we have multiple different errors that can occur inside a effect program. And the final one will be the dependencies, which we'll take a look also in just a second. Then we have here services, so to be able to reuse parts of code across our web application, across our code, instead of having to build this modularity ourselves using functions, using variables. This sort of improves the ergonomics a little bit more, and it also provides us with type safety by using effect. Because if a program that we use with effect runs a service, let's say that it yields a service, then it calls a function inside that service. If we don't have that provided to the program, to the effect program, then a type error will appear inside our IDE or inside the terminal when we run our program, and we'll be able to know if the program can run successfully or not. And this is, I would say, I would say that this is a thought that I had over and over again, that I used to have when working with Go. I still work with Go a lot. And also when I used to work with Rust, which is, if this doesn't throw a type error, then all of the stuff related to effect works correctly. All of the, not really the logic, because the logic can be flawed, but the types are correct, which means that I can call a service. I know that I have this available inside of the program, and a lot of different stuff that we can embed into the types system, into the types of our program, instead of having to do all kinds of runtime checks. So the services are defined in the following way. So we have here, as I said, the success, the error, and then the requirements, which they call requirements. These are essentially the dependencies. And to be able to provide a service, we can use this function. And we also have other ways to provide services. So to initialize it, we declare here a tag for a service that generates random numbers. This essentially tells our program what the shape of a service will be. So this will be a function or a service actually that generates a random number, and it includes only one function here, which is actually also an effect, which will return a number. So this essentially means that we'll be able to instantiate or initialize the service, and the service that we create needs to have this next property here, that is an effect that returns a number. And if we take a look here, the success case is a number, the error is never, and the dependencies or the requirements is also never, meaning that this program will never return an error, and it also doesn't require us to pass any services as dependencies. So a couple of keywords here that we have the service, we have the tag, which is a unique identifier representing a service. So each service needs to have a tag so that effect can keep track of it. And then we have the context, which is the collection story service, functioning like a map with tags as keys and services as values. So this is basically the context of an effect program that includes all of the services that it has available to it to run at each time. So then to implement this, we can, as you can see, we have here this random service. We yield this with a star here. And then we have available to us here the next property. And by yielding random.next, we get a random number back. And now here, if we want to run this program, we would get an error. And that's because we don't have the requirement actually passed into the program. So to be able to do that, we'll do the following things. So as you can see, we first of all declare here the random service. Then we create here the program that will use the service, and then we run this with run sync. And by passing here the program, we'll get an error type, an error that says argument of type effect void never random is not assignable to parameter of effect void never never. And this essentially means that we want to pass this random dependency, which we haven't done yet. Usually when we have something like effect void never never, and then we have a type that is not assignable to that, we look at this first type that we have here, and we can see the things that are missing when it comes to dependencies when we want to run this program. Now, to provide the service, we use the provide service function, and we pass the program, and now we have here the runnable program, and it now runs successfully. Then we have layers, which are essentially a way to be able to pass stuff into programs without having to manually specify the things that we want to pass into the program. This is a bit hard to explain, so let's take here a look at the documentation. In the managing service, you'll learn how to create effects. However, if we have a service within our effect program that has dependencies on other services in order to be built, in this case, we want to avoid leaking these implementation details into the service interface. So the solution to this is to use layers. So this is a dependency graph that we use to be able to pass stuff into, let's say, nested programs with effect, and still be able to pass those dependencies to that nested program without having to manually specify it along our programs. So we have here the concepts, the service, which is a reusable component providing specific functionality used across different parts of an application. We have the tag, which is a unique identifier, and then the context. This is a collection storing services, and finally the layer, which is an abstraction for constructing services, managing dependencies during construction rather than at the service level. So like I said, if we want to pass something that is nested inside of our dependency quote-unquote tree, we don't have to do that manually and leak those implementations. So a good example here is of a config. So we have the application configuration with all of the database, for example, the database URL and those kinds of things. We then have also the logger and the database. And inside of the database, we need to have access to both the config and the logger. But when we call here the SQL, the query actually method with the SQL argument, when we essentially want to run a query inside the database, we don't have to pass here this into the effect. So by doing this, it would expose config as logger as a requirement, and we don't want to do that manually. We rather want to specify that in a different program, and then if that program calls this one, that other program deals with the fact that it either has these things available to it or not. So here, like I said previously, we have no dependencies required here. Service function should avoid requiring dependency directly. In practice, service operation should have the requirements parameter set to never. So the idea here is that when we call stuff here, let's say the query, ideally this here should be never, because we don't want to pass these things manually, quote unquote, let's say, into here the effect. So this here would be a known and never, and this one would be omitted, which would also be never. So here we declare a test. It basically explains to us here how this would leak and the problems that it would cause. And then it explains here how to create layers. So we have here this way of creating a layer. There are also other ways, which we'll take a look at in just a second. I almost never use this way. I use a class with effect.service. And then we have here the example of the logger. So let's skip over this. I just want to see exactly where the part with the effect.service. So if I search here, effect.service. So like I said, simplifying service definition with effect.service. By doing this, we define a cache service. We pass here the exact same name that we have here, and then we say here app/cache. This is the key that will be used inside the context of the program. And then here we create the service. So we say here effect. If we want this to be scoped, which we'll also take a look at the scopes in just a second, we would say here scoped. And here this needs to be effect.gen. So this is an effect. And then it yields here the file system, and it does here some things. And to specify the dependencies, we pass here this inside the array. So now let's skip over to the other part. We have resource management. Here we'll go over the scope. The idea of the scope is that we have a way to have specific code that runs inside of a scope, and then when this scope ends, when this scope is quote unquote destroyed, let's say, at the end of the scope, then we have the ability to run particular code. We have the ability to essentially clean up our code. This is something that is more common in the Go ecosystem. And for example, to do this, we use the defer keyword to be able to clean up stuff when we finish running a function. This is a bit different because we are able to sort of control this a little bit more, and even manually cleaning up scopes inside of our effect programs. So to create a scope, we use the make function here. And then to close the scope, we use the close function. So destroy, close. It basically means that we want the scope to close. And to be able to run code that will execute before the scope is closed, we use here the add finalizer. So we say here finalizer 1 and finalizer 2. Now, one thing that is important to keep in mind is that this will run in a reverse order. So if we start here with the finalizer 1 and then 2, it will first run the 2 and then the 1. So like it says here, they run in reverse order. Usually the way we would use this is inside of a program. We say here yield and add the finalizer and then run stuff here. In the program that I'm building in the web application, I'm using this to be able to clean up event handler. So if I say, for example, window.add event handler to be able to listen, or actually WebSocket.add event handler to be able to listen to WebSocket being open or closed, then I want to be able to clean up those event handlers or remove them. And to be able to accomplish this, this is very useful. So this is basically the idea of it. We also use this when it comes to pub sub. So we have specific scopes, and at the end of a scope, we want our publisher to essentially close, to stop emitting new messages. And it is also used for that. The cool thing here is that we need to always pass a scope, and effect needs to know that it exists at compile time. So when we run our program, or rather when we create our program, when we build all of our stuff, we need to ensure that this exists here. And if we take a look at this part here, it says here never. And the type signature is scope. I'm not really sure if they have here the example without the scope. But yeah, essentially, if we don't have a scope, the error that we would get is that it expects effect string never never, and it has, or rather, it expects this and has the scope here, which means that we would need to wrap this around a scope effect, and then we'll be able to run this. Now let's take a look here. We'll skip over the observability, and we have also scheduling, which is basically stuff to be able to run things in a loop at specific times. And we also have here state management. Now this is also one thing that we'll go over when building this web application, and this is refs. The idea of it is that we want to be able to have state inside of these refs, and even be able to run them between different effect programs and share state that way. Also, one cool thing is the subscription ref, because this provides us with a stream. We also have the pub sub functionality, which we'll take a look at in just a second. And by combining pub sub with a stream or simply using the stream directly, we are able to have a ref to a particular state and listen to those changes using a stream. So if we see here, let's just search for the changes. So we have here the changes just to see how it is used. As you can see, we can say here run collect. It collects all of the the data that it has here, all of the chunks from the stream, and then we take here the amount of chunks that we want. In this case, we pass here the n, which is a random number. So the idea of this is that we want to have a reference to something that we share across our programs. One of these things will be, for example, a connection to the WebSocket. So if we have a WebSocket connection, we can have a reference to that and share that across different effect programs. And we can also use this to be able to share things like the current state of the connection, if it is successful, if we don't have a network working. So if we have, let's say, our Wi-Fi disabled and stuff like that. So if we continue here, we have caching, concurrency. Like I said, we have here the pub sub, and this can be combined with a stream by using the toPubSub function to be able to turn a stream into a pub sub, and we'll also be taking advantage of that. I'm going to skip over all of this stuff because now we get here into the streams. I'm not really going to get much deep into that in this video. And then we have the schemas, which allow us to um, to basically be able to have HTTP requests. Now, this obviously has a lot more stuff that we can do with it, but the use case that I'm going to go over, and since I'm mainly building web application, is having HTTP requests being made, and also having WebSocket connections open, and then the data that comes from the WebSocket connection will be parsed by using here the schema part of things. So if we just take a look at this here, we're able to essentially encode and decode information, sort of the Go Marshall and a Marshall side of things, and have consistent errors occur inside of our program. Like it says here, as a general rule, schemas should be defined such as encode plus decode, return the original value. So, okay, this is not really what I want to say, but the idea here is that if we have a schema and if we have a way to be able to run a program, know exactly where we are parsing, and knowing that it can throw an error, our server for any kind of reason can return stuff that we do not expect, and we want to be able to handle those errors properly and not crash our entire web application, and also provide errors to the end users, log stuff, and it has a totally different user experience at the end of the day, which, like I said, is the most important thing. So this is basically, this is everything. This video was a bit longer than the other ones, and I sort of improvise everything. So just to conclude, if you want to join this program, this course actually, when it is released. So again, I'm going to build a real-time web application, maybe something like a Pomodoro web application that has WebSockets to be able to make things real-time by using Go, because it has a lot of strengths when it comes to building WebSockets in the server, and then using Svelte, because at this point React is really a very much a very confusing ecosystem. So I'd much rather use Svelte when it comes to building stuff with TypeScript on the front end. So if you're interested in that, I'm going to leave a link in the description down below, and also leave actually a comment below and let me know what you thought of this. If you're interested in learning more stuff about effect, svelte, go, the combination of the three, or any sort of combination. And I'll see you on the next one.